All right, we're going to look at solving systems of linear equations by graphing. And what a system of linear equations means is that you have two or more linear equations with the same variables, okay? So we're going to be working in two equations, and the variables would be y and x. So in these cases, in order to graph, you make sure that they are in y equals mx plus b form, which is our slope-intercept form. And in our case here, y equals x plus 2 and y equals 3x minus 6 are both in slope-intercept form. So for each equation, you're going to pull off the slope and the y-intercept. So for our first equation, our slope is 1, and since it doesn't have a denominator, we put it over 1. And our y-intercept is 2, giving us the point 0.02. We'll graph that in a few minutes. Our other equation here, y equals 3x minus 6. We pull off our slope and it's 3, and it's over 1 since it's an integer. And our y-intercept is negative 6, giving us the point 0, negative 6. Now we're going to take those 2 points and we are going to graph them. Okay? And when we graph them, always identify your x and y axes. So I'll put that down a little lower. Okay, so this is our x-axis, this is our y. And first I'm going to graph the y equals x plus 2. So our y-intercept was 2. So put a point there. I go up 1, right 1, and I'm going to walk it a few times. Up 1, right 1. And I could reverse it. If I'm going up and right, I can go down and left. It's still a positive answer. And then it gives me a more accuracy of the line. And you take a ruler and you graph your line all the way through the coordinate plane. Arrows on both ends. But you want to go through the coordinate plane because you're really not sure where your other line is going to go. So you need to make sure it's long enough so you can intersect. All right, now the next line, y equals 3x minus 6. Now y-intercept is negative 6. So 1, 2, 3, 4, 5, 6. So right here, okay. And our slope is 3 over 1. So going up 3 and right 1, up 3 and right 1, up 3 and right 1, up 3 and right 1. All right, and that's another reason why I do like to continue my walking of my slope, because sometimes where you start with your y-intercept is not quite where you're going to intersect. It's not even close to where you're going to intersect with these lines. Okay, now, when you say you're solving for a system of equations, by graphing, you are looking for where the lines intersect. Okay? Where lines intersect is what we're looking for. That's our solution. So our solution in this case is the point where our lines intersect, and they intersect right here, okay? At this point right there. So we're going to count 1, 2, 3, 4. So your x value is 4. And then we're going to go 1, 2, 3, 4, 5, 6 up, and it's 4, 6. Okay? So that's our intersection point. Now, to check, which you really should always check, is you substitute in the 0.46 into both equations to see if it winds up being equal on both sides. So our y is 6, our x is 4, plus 2. That's our first equation. 6 equals 6, and that's true. So it checks for that equation, which means that this 0.46 is on y equals x plus 2. Let's check with the other equation, y equals 3x minus 6. We plug in 6 for our y. We plug in 4 for our x. We calculate 12 minus 6. Our equation comes down 6, and 12 minus 6 is 6, so it checks. So what this means is that 4, 6 is a solution for both of these equations. And we've checked our work, so therefore our graph is correct. And our solution, which we have to write separately off of the graph, is also correct. Now, there are a lot of things that can happen when you are graphing a system of linear equations. You could wind up with one solution, which means both of your lines intersect at one point, which we just found out. You can also wind up with no solution, which means when you graph each individual line, they wind up being parallel. And the way that you can tell that they are parallel is that they have the same slope when they're in slope-intercept form, or y equals mx plus b form. And then sometimes you can have, when you manipulate a line and solve the equation for y, you get the same exact equation to graph again. So one line overlies the other line, which means that all the points on each line touch each other. So there's infinite solutions, okay? So one solution, two separate lines, they intersect at one point, one solution. Parallel lines, they'll have the same slope, and there'll be no solution because there's no intersection point. And a line that overlies itself means that there's infinite solutions because every point on the line touches every point on the second line. So that would be infinite solutions. So let's look at another problem. Okay, we have y equals 2/3 x plus 1 and y equals 2/3 x minus 4. So if you're astute and you kind of catch it, you can see the slope here for the first one is 2/3 and the y-intercept is 1, giving us the point 0, 1. And in our second one, we have the slope is 2/3 again, so that's a clue. Our y-intercept is -4, giving us the point 0, -4. But if you don't catch it here, that the slopes are the same, so therefore they're parallel lines, okay, and there are no solutions, then you graph it. So same slopes here. Therefore, there are no solutions. In other words, our two lines are not going to intersect. Now, if you're required to graph, which we are in this case, we are going to support our knowledge, our conclusion from the knowledge we have, that we're going to have no solution here. So let's graph our first line, b equals 1. Okay, our y-intercept is 1, and our slope is 2/3. So we're going to go to 1. We're going to go up 2, right 3. I'm going to go up 2 again, right 3. I'm going to go up 2 again, right 3. And I'm going to reverse it. If I went up and right, I'm going to go down 2 and left 3. Down 2 and left 3. Down 2 and left 3. Just gives me a pretty accurate line. And draw your line all the way through your coordinate plane. Way through. And make sure you line up those points well, okay? All right, now, next, we're going to graph y equals 2/3 x minus 4. So our y-intercept is -4. We're going to go up 2 and right 3, up 2 and right 3, up 2 and right 3, and I'm going to continue in reverse. I'm going to go down 2 and left 3, down 2 and left 3, and down 2 and left 3. And I don't see any intersection here, and sometimes you could think, oh boy, I might have graphed that wrong, but let's take a look. And what you notice is that since these both have the same slope, there are parallel lines, so therefore no solution. And if you were explaining why there's no solution, it's because they are parallel lines. Okay, so don't say that the solution is parallel lines. It's a no solution answer. That's your answer. The reason is because they are parallel. All right, now, things are not always given to you in the form that you like, so therefore sometimes we have to do a little manipulation. So in this case, we have -x plus y equals 7, okay, equals -7. So we're going to take that equation and we're going to change it into slope-intercept form. We'll add x to each side, y equals, x term always comes after the equals, and then -7. Now you can take off your slope, which is 1, so we put it over 1 because it's an integer. And our y-intercept is -7, giving us the point 0, -7. All right, we're ready to graph that one. We'll do in a minute. And the next one is x plus 4y equals -8. We're going to solve again for y. We got 4y equals -x minus 8. Divide by 4. y equals. If you remember from previous lessons, the number in front of that x is a -1, so that's the coefficient. Separate the coefficient of 1/4, which is the entire number in front of x, from the x so that you can get your slope. 8 divided by 4 is 2, and it's still -2. And for that, it gives us a slope of -1/4 and a y-intercept of -2, giving us the point 0, -2. All right, so now we're going to graph. Our x and y axis is here, clearly labeled. We'll graph our blue line first, which is -x plus y equals -7. And we got a y-intercept of -7. So 1, 2, 3, 4, 5, 6, 7. And we got a slope of 1/1. So we're going to just reverse it and have it go forward and get a nice clean line. Okay, give a few points there, helps get a pretty accurate line there. Okay. And now we're going to do our second equation, which is the x plus 4y equals -8. Our y-intercept was -2, and our slope was -1/4, so down 1, right 4. And bingo, you can already see the intersection. But walk it again, down 1, 1 over to the right 4. And that should be enough for us. And we graph our line. We'll do it this way to make it a little more accurate. You still have to finish the graphing of the line even though you can see your intersection point, so you must do that. And now you have to write your solution. Your solution is the intersection of both of these graphs. So it's at 1, 2, 3, 4. 1, 2, 3 down, so 4 to the right, so it's a 4 positive and -3. That's our intersection point. And again, you should check this by plugging into your original equations and seeing that they equal to -7 and then -8. Okay. All right, and our last problem is going to be y equals 2x plus 1 and 2y minus 4x equals 2. Oh, sorry, that should be equals 2. That's my fault there, so equals 2. Okay, so what we're going to do is we're going to manipulate our second equation. We already have our first one. So we're going to take 2y minus 4x equals to 2. And we're going to add 4x over to each side because we have to get this in slope-intercept form in order to graph. So 2y equals 4x plus 2. We're now going to divide by 2 on each under each term. So we're going to get y equals 4 divided by 2 is 2. Keep the x. 2 divided by 2 is 1. And what you notice is that you have the same equation here for the second equation that we just manipulated and the first equation. So when you graph, you're getting the same equation twice. So our slope for this first equation is 2/1 and our y-intercept is 1, giving us the point 0, 1. And our second equation, our slope is 2/1. Our y-intercept is 1, giving us the point 0, 1. So we're going to graph. First we'll graph our first equation in green. So we're going to go to our y-intercept of 0. I'm going to go rise 2, right 1, rise 2, right 1, rise 2, right 1. And I'll work it backwards, down to left 1, once or twice there. Okay, and you got a pretty accurate line. All the way through the coordinate plane again. And now you're going to graph the second line over it. So our second line, which was red, okay, so y-intercept was 1. Our slope is 2/1, so up to right 1, up to right 1. And you can see we're getting the exact same line again. However, you do have to graph over it. So colors are usually handy here. And so your solution is every single point on the green and red line on both of these equations touch. So the solution is all points, all real numbers. So we say that it's infinite. That's the more sophisticated way to say that. It's infinite solutions. All right, so as a review, when we have the intersection of two lines and we have one intersection point, that's one solution. When we have parallel lines, meaning our lines have the same slope, we have no solutions. And when we have a line that winds up mapping right onto itself and graphed onto itself, that means we have infinite solutions. And that is how you solve a system of linear equations by graphing.